All right, let's take up this question. The hypotenuse of a right triangle, is 1 meter longer than twice one of the other two sides, which I called B for the base of the triangle. And the third side is 15. Find the lengths of the unknown side and the hypotenuse and solve by factoring. So when you have a question like this and you're not sure, like, how do I write up my equation, you need to think about what are the things that I know about what's given. So when you're given a right-angled triangle and you're talking about the lengths, not the measures of the angles, but the lengths, you know that these lengths have a relationship from our old friend Pythagoras. So you simply put these into Pythagoras' theorem. So we know that b squared plus 15 squared equals 1 plus 2b squared. And then once you do that, you then square it all out, put it in standard form, and solve by factoring. All right, let's do that. So here we have b squared plus 15 times 15 is 225. And then here we're going to square this out. So we square the first, square the last, and then this times this doubled is that. That's how we square out a perfect square trinomial. Okay, now we're going to bring everything over here and collect. So I've got b squared minus 4b squared minus 4b plus 225 minus 1 equals 0. So this and this need to be collected. So I've got minus 3b squared minus 4b and then plus 224. I'm going to multiply everything by -1, so this is positive. Oops. That's now a negative. And now we need to factor. So we need to figure out what multiplies by this, what this times this, what multiplies to that number and subtracts to 4. So we've got to get busy here. 3 times 224. 3 times 224 is, that times that is 2 carry the 1, that's 6 plus 1 is 7, and that's 6. So 672. So we need to figure out what multiplies to 672 and subtract to 4. This is not a short question, guys, but we're going to have to do it. So 1 times 672 obviously does not subtract to that. 2. This ends in 2, so we know that it's an even number. So how many times does 2 go into 672? 2 goes into 6 3 times. 2 goes into 7 3 times with 1 left over. And then 2 goes into 12 6 times. Those do not have a difference of 4. Let's see if 3 goes into here. 3 goes into there evenly. And does 3 go into 72? I'm pretty sure it does. So let's see. 3 times... So 3 into 672. So 3 goes into 6 twice, and 3 goes into 7 twice with 1 left over, and 3 goes into 12 4 times. Still not even close to a difference of 4. So does 4 go into here? Well, you know what, let's just keep skipping along because we've got to close this gap. 5 doesn't matter. Definitely 5 doesn't go in. It doesn't end in 0 or 5. 6, 7, let's bump up to, like, let's say, I don't know, 8. Let's see what happens with 8. If we've gone too far, then we'll go back. So 8 into 67, well, 8 times 8 is 64. So 8 times 8 is 64, and then there's 3 left over, and 8 goes into 32 4 times. Again, still not even close to having a difference of 4. Let's pick another number. How about 12? What happens with 12? So 12 goes into 672. Well, 12 times 5 is 60, and then 7 left over. And then 12 goes into 72 6 times. Those still do not have a difference of 4. Got to keep going and closing the gap. Let's see. Let's try 18. So 18, does 18 go into 672? Let's see, 18, 36, 36 and 36 is 72. So 18 times 3. So what is 18 times 3? 18 times 3 is 4, carry the 2, 54. And 54 up to 67 is 13. And then how many times does 18 go into 182? Guys, this is no 132, I mean. You see how detailed, and this is enough to drive you crazy. Okay, let's see, 18 into 132. And so, anyway, I'm just going to leave it there before I continue, and you need to find out which number it is. Just going to erase this. You need to find out which number it is that's going to work, and then you know that you continue on to do this. You let the two brackets equal 0 and you solve.